Hello guys, we are going to discuss this problem today, number of ways to select buildings. This is in Amazon's recent past 6 month asked questions, and the question is like this, that we are given an array of binary zeros and ones, and we need to find three buildings, that is select three buildings for random inspection. And the condition is that no two consecutive buildings should be selected of the same type. For example, if we want to select a building, we cannot select 0 0. Even we cannot select 0, this 1 1. So the valid selections would be 0 1 and 0, right? So after 0 there should be another a different kind of building selected, and after 1 there should be a different kind of building selected, that is 0. So the valid selections would be this, that is 0 1 and 0, then 0 and this next one and 0. Then we'll move to this 0 1 and 0, then 0 1 and 0, and then this 0, this 1 0 1, and then 1 0 1. So these are six valid like selections, six valid ways to select this. So there can be different ways to solve the problem, but what I have done is we will be uh, uh, counting uh, the number of zeros and ones before and after every before and after for every index. So why so? So if we see here, only two type of patterns can be there, that 0 1 0 one pattern and 1 0 1. So only these two are the valid patterns, right? Apart from these two, there is no valid pattern um, in this problem for selection of the buildings. So what we'll do is, for example, if we see here on index 2, so this is 1. So the valid pattern will be 0, 1 and 0. So what we can say about is the number of zeros which are before, if the value is 1, that is this one. So what we'll do is we will count number of zeros before this one. So in this case it will be 2, and number of zeros after this one. So in this case it will be 1. So we'll multiply those. So for index 2, if we say index equal to 2, all ways will be equal to uh, zeros before multiplied by zeros after. Because what we'll see here is on index 2 we have this pattern, that is 0 1 0, and we have two zeros before it and 1 0 after it. So the pattern, there should be only two patterns. So let's see what are those two patterns. So first pattern is this one, 0 1 and 0. So it will be for the index 0, index 2 and index 4. Then it will be for index 1, index 2 and index 4. So only these two allowed patterns or valid patterns are there. Similarly, if we have one more 0 here, for example, this becomes this. So then we'll have four patterns in this case. So how it is? This will be 0, 2 and 4. Then it will be 0, 2 and 5, right? 0 2 and 5. Then for the first one we'll have 1 2 and 4 and 1 2 and 5, right? So four patterns. So what we'll be doing is for every index we will be calculating the number of zeros before it and number of zeros after it, and also we'll be calculating number of ones before it and number of ones after it. And then we'll again iterate through the array and we'll multiply this and add the same. So let us directly go on to the solution. Okay, for this one, for this array, let us see. Okay, for this array, so we'll have four different arrays. That is ones before, ones after, zeros before, and zeros after. So if we see here at index 0, what are the number of zeros after this index? So it would be 1 and 2. So zeros after. So let's take ones before. So for 0, we do not have any 1 before. We do not have 1 before. This also doesn't have, but this one, this index has 1 before. This has two ones before, and this has only has two ones before. So this is the ones before array. And for ones after array, for this one, it has three ones after it. so it has 3. For index 1 also has 3 ones after it. For index 2 it has only 2 ones after it, so 2. For index 3 it has only 1 after it, so 1. And for this one it will have 0. Similarly, we can calculate zeros before and zeros after. So zeros before for this is 0, but for this is 1, right? For this is 2 zeros before it. It is also 2 zeros. For this one also 2 zeros, but for last it has 3 zeros before it. And what about the zeros after? For this one, this index, that is 0 index, we have 2 zeros after it. For index 1 we have 1 zero after it. Then um, we are on this one last array. For index 2 we have 1 0 after it. For index 3 we have 1 0. For index 4 we have 0 zeros, right? Because there is, after index 4 there is no 0. So if we have these 4 different arrays. Now what we'll do is we will uh, go through this array, original array. If we find 0, for example, if we find 0 here, so what we will identify is that what pattern we can have is we can have 1 0 and 1. So let me take this one here. Uh, okay, so let me go through to index I. So at index I equal to 0, this is 0. So value is actually 0. So what pattern we can have is for value 0, that is Si, we can say the index I is 0. So what pattern it can have is 1 0 1, right? So it should have at least 1 before it, then this 0, and at least 1 1 before after it. So since we do not have any 1 before it, so we can ignore I equal to 0. For I equal to 1 it has 0, so again it can have this pattern 1 0 and 1. So what we will calculate is how many number of ones are before it. Ones before, how much are there? Let me just, okay. So once before, uh, this is 0, and once after, this is 3. So 0 into 3, this will be 0. So let me just have a count here. So this is 0. Then we'll move at index 2. So in index 2 value is 1. So the valid pattern will be 0 1 0, right? So so valid pattern is 0 1. So we'll calculate number of zeros before it. So number of zeros before it are 2, right? And multiplied by number of zeros after it. So these are the before and these are after it. So for this one, this will be 1. So it will be 1. 2 into 1. So it will be 2. For index 3, similarly, it's 1. So the valid pattern will be 1 0 1 0. So we'll take number of zeros before it and number of zeros after it. So this one here. So again it will be 2 into 1. So it will be 2. For 4, it is 0. So the valid pattern will be 1 0 and 1. So what we'll see is number of ones before it, number of ones after it. For index 4, so number of ones before is 2 and number of ones after is 2. So it will be again 2 into 1. So it will be 2. And for index 5, uh, it's 1. So pattern can be uh, 0 1 0. So this is not a valid pattern, and hence uh, we will ignore it, and its answer will be 0 because there is no 0 after it, right? So that's why. So the total count would be 6 here, right? So let's go into the code. Um, so we have the string here. So first we are calculating ones after and zeros after, right? So how we are going? So we have taken two arrays, that is ones after and zeros after. So we will be taking ones after this one and zeros after this one. So let me just take it right here. Ones after and zeros after. So initially both arrays are 0. So we will be finding the ones after and zeros after for the index 0. So for index 0, what we'll have is something like this. Sorry, 0, and this all will be 0 as well, right? Because for this one, this index, there are 3 ones after it, and for this index, there are 2 zeros after it, right? This one. So now what we'll have is we'll store uh, 1 is equal to 3, and we'll store 0 is equal to 2. Then we'll iterate through the original array. If it is 0, so in the first case, so we will start from 1. So if it is 0, so in that case, we will decrement 0 and we'll keep ones as same. So in this case, this is 0. So what we'll do is we'll have 1 here. We'll decrement 0 and we'll keep zeros same. So what does this mean? This means that on this index, whatever zeros were present, we have decremented 1 from it, right? And since this is 0, this is not 1, so number of ones after it will be same, right? So now at I equal to, so this becomes at I equal to 1. Now we have I equal to 2. So at I equal to 2, we are at this place. We found that 1 is here, right? So we will decrement 1 from it and we'll keep 0 as the same because there is no change, right? Then at I equal to 3, we'll find 1. We found 1, so we'll decrement 1. We'll keep 0 the same. At I equal to 4, we found 0, so we'll decrement 0. We'll keep 1 as same. And finally, we found um, 1, so we'll decrement 1 and zeros was already the same. So finally, we have this 1 after this one and zeros after this one, two arrays. And similarly, we'll calculate 1 before and zeros before. So we'll traverse in the reverse direction from back to front and we'll fill it. And finally, what we'll do is we'll go from I equal to 1 to size minus 1. If we have as I equal to 0, so we have these four arrays now. So we have I equal to 0. So in this case, we will see for I equal to 0, if Si is equal to 0, so the valid pattern will be 101, right? So we'll take ones before and ones after. So ones before is 0 and ones after is 3. So it's 0. For I equal to 1, so valid pattern will be 0, 1, 0. So we'll take zeros before and zeros after. So in this case, it will be 2. And similarly, we'll keep on adding on to the count. And this solves the problem. So the overall time complexity for this will be O(n) because we are doing 4 for loops and those are not nested, so O(n), while the space complexity would be O(n) again because we are taking 4 um, vectors or 4 arrays, which is same as size of the string if size of string is n, and that's why we can say 4n is equal to O(n). So that's the solution for this problem. Thanks a lot, guys. Have a good day.